A coroutine is a concurrency design pattern that you can use on Android to simplify code that executes asynchronously.
So you have your UI thread, main thread, and you want it to be always responsive. So you'll have the code, the tasks, and if in synchronized way, and your task is long running, and if it's on your main thread, your UI thread, it can block the UI. So your UI will be frozen and hung. And use coroutine, you can get your background coroutines which will not block your main thread UI, so your UI can be always responsive. So we can start create a project, open your Android Studio. And let's create a new project, and phone and tablet, empty activity, and we say Kotlin Coroutine. Exclude folder, Microsoft Defender, then you're not getting a performance issue. Okay, so exclude it. Okay, now run the application. We can see the default Hello Android, and let's make a quickly move the greeting into a page. Let's say quickly say we add a new package, screens, and we create a new screen of Kotlin class, and we say this will be the coroutine screen, and new coroutine screen, and we can just cut this into our coroutine screen. So this is composable, and this function we change to coroutine screen. So main activity is starting point, and instead of calling it greeting, we call it coroutine screen. Coroutine screen, and we call the instead of greeting, we call coroutine screen, and import function coroutine screen. So it will be import over here, and this will be coroutine screen. So everything is the same. Instead of we just created a package of screens, and we move the greeting into a separate screen file, and everything should be still running exactly the same as default. Okay, still the same. and go to actually what you see is rename, refactor, rename, coroutine screen without spelling error, refactor, and all good. And go back to this. We don't need the name, and we remove the name. We just say hello, and in this we remove the name. So and it's all the same. For the coroutine screen, let's say right now we only have a text. So if you see, the coroutine screen is running on the main thread, the UI thread. And if we have some task, and which is a long-running process, and if you run the same thread of the main thread, and the task is long-running, it can block the UI thread, and which will be the user interaction will not be responsive. So let's say we have a long-running process. Let's create a long-running process. So let's say we have a text, and we have a button, and the button it says as a text of run, and the on click will be, let's say we have a function, let's create a function. Let's say we create a function. This is a process. Process will return long type, and let's say we have our x, which is type of long, equal to 0. It's a long integer, and let's say for I in 1 to 10, and we say x equal to x plus I, and x equal to x multiply x. So suppose we have in the main thread, US thread, we are going to run a long-running task. Let's say we call the process. We are running the same thread, right? The US thread. We simply call this function, and let's say instead of there's a text and button, and let's make this in a column. So let's run it first. Return x. Okay, still we have hello, but the button is about the let's make it in a column. So let's say column, column, and move everything into a column, and let's run. Oh, now we click on run. It still say hello, and let's stop. We say we create a variable and bind it into the text, and we say x is type of long integer equal to 0, and we say the x value is $x, and the process, which we can say x equal to process. Let's run. Oh, sorry. $. Okay. So I didn't see the update of x because it is didn't the x we need say I remember because the state is not refreshed by I remember mutable state of 0, mutable state of initial value is 0. Okay, we need getter and so this will be say let's say import need a getter and setter, and it's the compose dot runtime dot get value, and I can get set value to set value. Mutable state. Oh, all right. So now we import the function. So the mutable state, which this is an x right now, is mutable state, and it's when it's a state change, so the UI, the text binding, and will be like say observed the state and will get the value. So this by is say if you use equal and it will be mutable state of the int, the type will not match, so you will say you need to use by. And now let's run the application. So after run this long running process, it should be updated the x value. Run, and the value is changed. And let's make this a column. So we have text, we have a button. Let's make the UI a more we like to make it scrollable. So say we have to make the column scrollable, we just say modifier, which will be equal to modifier. That let's say first say it will fill max size, and second say it has a padding of 16 BP. And then we can say we want a vertical scroll, and this will be remember scroll state. The state is remember scroll state, and to make more content. So to make more content, we just say for I in 1 to 100. We got lots of text. The text is demo. Let's run. So to say if the task is running async in the thread, if it's long running, it can block the UI. Let's see. For now, our application is running smoothly. There's no task block the UI, so you can see when we scroll up, scroll down, everything is good. And click, we got the value. But that's only because, let's say, this this function of process, it only run 10 times. Let's make this, let's say we want some alignment. We say horizontal alignment, which equal to alignment central horizontally, and vertical arrangement, we want arrangement of central. Let's run the application. So in this column, we got these modifiers. And click on run, everything runs good, and the UI no problem, and even this process is running in the UI thread. But if, let's say, if we got this number bigger, and we run, let's click on the button, run, and you can see, oh, it froze the UI. The UI, let's say, is in the sync mode, because this function of process, you can say, the Kotlin coroutine is not responding, because this process is a long-running process, and it blocked the UI, and then it got the Kotlin coroutine. This application, our application, is not responding to the UI interactive, and we can say close app. So that's the problem. If your process, let's say the functional process, if your task is a long-running process and is on the same thread of the main thread, the UI thread, it will block the UI to be responsive, and the user interaction on the UI will be blocked. And to solve the problem, we can say, instead of we can use coroutines. So instead of the regular function, we can say, we can create a suspend function. So let's copy this process, and simply we say suspend, and now we got a suspend function, and we call it async. This function now, the process async right now is an async function. And you can see we wanted running on a background thread to not block this process async will not block the UI thread. So to say suspend function, and the dispatcher, we want to use default dispatcher, which is CPU intensive work. So let's say our suspend function process async, which will be running the task with context, and the dispatchers will be default, and running this process okay. Now to run this long-running process in a CPU intensive work in a dispatchers default. So on this thread we run this long-running task, and this suspend function can only be run in a coroutine. So to call this process async, you cannot say, let's say, instead of you call the x equal to process, you want to say x equal to process async, and you got an error. Suspend function can only be called from a coroutine. Okay, so we can say we remove this button, and we create another run synchronously, run sync. So how to run the synchronously of this process? We create another button. Let's copy and put it here. So then this will be say run asynchronously, and this will be we need a coroutine scope, and this coroutine scope, let's say we define coroutine scope over here. We need a coroutine scope, but coroutine scope which equal to, remember, coroutine scope. Need this function. This is that Android Compose runtime. Remember coroutine scope, and then we can use this coroutine scope in our buttons. Is run async. Then we can say coroutine scope dot launch, and we can say x equal to process async. So to call a suspend function, you need run it inside the coroutine scope dot launch. The launch fire and forgot, and until it return the jobs, and so now let's say it's still the same long running process. Let's run the application. Let's run async. Oh, you can still move the it's a scrollable row column, so you can still move it, but the process is running right now is running in a coroutine. The button is in a coroutine scope, and it launches, and the process async process coroutine the suspend function is running inside the coroutine scope, and it's a long running process. After it finished, so the launch will be fire and forgot. So that's why this process didn't block the UI thread. So the UI is still responsive. So you can scroll down, scroll up, and when this X changes, the state changes, it's in a mutable state. When the value changes, it will update the UI, the text. The text, because there's a binding of the variable of X. After the process is finished, and it will update it. And let's say this process is running too long. Let's stop it. Let's say we make it a little bit smaller. Let's say X. Okay, so sync process is long and sync is not working, and the application crashed. Run async, and you can see the value. I got the value. And let's even make it a little bit bigger. Run async. The UI thread is not blocked, and the value will be updated after the process. using coroutine, and I can use the US right is our coroutine screen, and after using that this inside this button, using this coroutine scope, we run our function, suspend function, in background thread, so it will not block the main thread. And after that, the long running process, and says the x value is changed. So using coroutine, and we can run the long running process in the background thread instead of the main thread US thread. So any long running process will not block the US thread, and our application which is still responsive. Okay, one more thing. Let's say so here we got the same number for this for loop, so the calculation will be the same. Let's run sync, and async is the same, and we want 1 2 3 4 1 2 3 4 stop. Right, this process, long running process, are doing the same calculation. Let's run sync, and okay, stop. 1 2 3 4 1 2 3 4. And now the process is running longer, and the process in this sync is now suspend function. It's on the same thread of the US thread, and it blocked the UI. It's now responding. Close application. The same calculation, same long running process. If it's run async, it's running in coroutine, and on the launch, it's fair and forgot, and only one process finished returned, and we'll update the state of X. So the UI block, the US thread is now blocked. The process is running in background thread. The main US is always responsive if you're using the coroutine, and your task is running in a background thread, which is the dispatcher.default, which is used for running CPU intensive work. In your coroutine, you can have multiple tasks, and you can execute these tasks sequentially or parallel. So for example, if let's say we have the button, got a new button, so we run sequentially. So run sequentially, and to run it sequentially, let's say we copy, use this suspend function. Say this is the multiple task, the process 1, and we have process B, process A, process B, and to run it sequentially, so we can say we have a variable of y. It's a mutable state, and we have a text which will bind into y, so the y over here, and to say run sequentially, we say x equal to process A, and after that in the coroutine scope, it run first, it run x equal to process A. After it finish, it run y equal to process B. And let's play. Click the play button. That's right. Run sequentially, so you can see x over here, and the value, the y value is y. Run sequentially, you can see first after the process A is finished, it shows the x value, and wait after the process A is finished, and then it's starting running the process B sequentially. After process A finish, it's starting running process B, and after that it display the y value. And let's say to do the parallel execution, so they are running in parallel after both of them finish, and then return the result. So let's say we duplicate this button, and then we say run parallel execution, and so in the coroutine, it will be raw. Oh, we say you use the keyword async, and inside the code block, you say x equal to, say the, say you can say wall defer the result, right? It's deferred 1 equal to async x equal to process A, running process A, and the same thing of defer 2, which will be y equal to process B. So in this way, use the async, use the keyword of async, and they will run in parallel, and then we can say var result equal to await all defer A and defer B, defer 2. So in this way, there will be execute the process in parallel. Let's say we run the application. Run parallel. So you can see none of them changed, and the same time, the x, y, and the y value is updated at the same time. So they are running in parallel, and after await all after all of them finish, and the x and the y the state is changed both same time. Okay, that's the parallel execution using async and await all, and you can get a try catch block inside of your coroutine, you can say, you can always use try catch. Try this and catch evil exception. Try okay, so inside your coroutine scope, and you can use the try catch block. So result, you can catch the exception and say, you can say print e dot message, and yeah, you can use timeout. So the coroutine actually is lightweight, built-in cancellation, sequential like code, you can sequential like code, and exception safety. You can use try catch. Okay, next we are going to have an example for the real world use of coroutine, which is API calls, network calls, and background thread. So let's go to our application. Instead of we got a new screen, create a new screen, Kotlin class, and say posts. Post screen. So we are going to call the API by calling API to the JSON placeholder. JSON placeholder, you can see the posts. We are going to call to posts, and this will be, let's say, composable. Let's copy this. The post screen. Post screen, and only have a text of post. And we can say to the main activity, we just simply change this to post screen. Okay, so now we have a post screen. Yeah, post screen. And let's go to post screen. Let's create this in real world. Mostly probably use the pattern is MVVM. So we are going to use MVVM, and we create a package called ViewModel. And we are going to add a new Kotlin class of post ViewModel. And we have our post ViewModel. And you can see we are going to use in ViewModel, we're going to use ViewModelScope.launch. This is the coroutine call, and we are going to have the network on suspend function. So let's go see the JSON placeholder dot. Let's go to this URL, see the posts, and you can see the posts contain user ID, title, and body. So for the class, data class, we are going to have a package of model, and we are going to have data class of post, and this data class post. So in the constructor, which we have user ID of int and ID of int title of string and body string, and for the API service, let's create a new Kotlin class called repository, and inside we create a new Kotlin class called object. Actually, it's an object of the API service. So now we have object of API service, and we need a JSON decode. So we can say private or JSON equal to JSON. This is JSON object return from the API is in JSON format. So we are going to have JSON. And this JSON, we need the serialization. What we need is you can see the JSON serialization. So from the JSON format to the Kotlin data object, we need a serialization. So what we need is apply Kotlin serialization creator plugin. Let's say plugins. Let's copy this. Go to this. Apply first. And we also need to go to the module, and we need implement dependency. Okay, sync now. Go to API service. So this is a JSON format. We need to serialize to the data class. So what we need is make a class serializable by annotating it with at serializable. So let's copy at serializable. Go to the model post, and we say annotation of serializable, and go back to the Let's say create a new package repository. And now this one. Remove this one. Just delete. Oh yeah. And repository package. This is our refactor. Yeah. Auto repository is API service. So this we have this will be JSON, and this will be ignore import JSON. Is from Kotlin X serialization.json.json, and we are going to ignore unknown keys, which equal to true. And in the for the coroutine the operation, we need the suspend function. So to get posts, we need to say suspend fun, and get posts. We pull the posts from, and this will be return list of generic of list of posts, which equal to with context. So we are going to run this in the dispatcher.io. Dispatch. Posts. Let's see the post. Oh yeah, it's because this we need to import. That's okay. Now we go to API service. We can import posts. Show contact action, import class post. Okay, now we can see which equal to this context, and the context will be dispatchers dot io for network operation. And inside this, we can say wall response equal to URL, and the URL will be copy this, the URL, read text, and we can say return JSON. That's our JSON dot decode from string of response. Okay, so you can see got the string from this URL. This is a Java.net URL. It got a network operation call, API call to this URL address and read a text. And this text will be decoded from string. And the JSON use the JSON decoder, decode this response string to our post serializable data class. So that's the API service object. Can call to this, and perfect. That's for API call. It's in a suspend function. And for the post view model, this will be type of view model, and we can say first we want the post provide private wall posts local equal to mutable state flow type of list of posts, list of a generic post, and post in show content action in purpose, and this should be default empty list. And for the view model exposed property is post, and which is local dash post. The property is post is state flow type of list of posts. State flow, which equal to local variable posts dot as state flow. So that's the view model. So in the view model, we got the call to the repository, got a network call, and get the list of posts, and we expose it as a state flow to the view, right? And but it also during the network operation, it's loading the state of its loading. So we can say private wall is loading this mutable state flow and false. The default value is false. So the exposed state flow is loading equal to state flow type of boolean, which equal to local is loading as state flow. and it could the network call API service and the network call can exception. So we can say it's like a 441, 402, 400. Exact. The API call can got any type of exception. Or we are, let's say, private or error go to mute post flow, and the initial value is false, and while error equal to is type of state flow, and type of nullable string, and this is get from local variable error as state flow. Now, okay, initial value is now, and so that's the view model post to the view. Okay, post is loading arrow. This is the view's state, and this is the post, and we'll have the regular function fetch posts. This function will run in the views, will be called by the view, and we got a view model scope. So in the view model, instead of the coroutine scope is general scope, and inside of view model, it's view model scope, and this will be launch, and call the suspend function. And before call the suspend function, we can say first is loading equal to true, and this is the mutable state flow, and this value is equal to true. Error value equal to null, and we get our network operation in a try catch block. Try catch exception. Try catch block. Inside we fetch our result equal to API service dot get post. So inside the coroutine, we got the call the suspend function of get post, and that's now. So our local variable post of value will be post mutable state flows value of mutable state flow, and dash post value will be result, the list of post data class. And if it's error, we can say error the value, which will be equal to error, and $sign for interpolation, and then this will be e.message. And finally, no matter is success or there's exception, anyway, we want set is loading to false. Okay, so that's our view model. And for the view post screen, now we can work on our view. First, we got constructor, we got our post view model. So we can say view model, which type of post view model, and which equal to view model. View model. We needed a function of let's add this to the dependency view model sync. Okay. Okay, so now we can click our state flow from the view model. Let's say for posts, we can say by if you use equal view model dot posts dot that's the is post state flow dot collect as states. Now click the collect as state the states from the view model, right? And if it's equal, it has the value, right? And we just use the by to directly get the value from use by to get the state flow posts value. So that should be the posts. It's a state flow list of posts, and we want the value is the list of posts. So I got the use the by keyword to get the post is actually state flow. The value is state flow. So directly is the post collect of states value. And folder is loading. You can say by view model that is loading a collect as state. Same thing as error. Error is by view model dot error dot collect as state. I got the state of is loading, got the posts, which is the list of posts, and got the error as a string. And we can say we want to have a column. We put everything in vertical, so in the column we can say actually we need a modifier, right? Modifier, go to modifier dot fill max size hiding 16 dp. And vertical arrangement equal to cut from top arrangement as space by space by 16.dp. Okay, now we can see first we got the view state of it's loading and error. So let's see. We have a button and this will say if it's loading, else, right? And else state is loading, and if it's loading, we can say circular progress indicator, and the modifier will be we gave it a size, modifier the size, and that should be 24 dp. And spacer, and then that should be modifier, go to modifier, white, width 8 dp. And you can see text of loading. Other than that, if else, we can say text of fetch post. And for this button, for the on-click, the buttons on-click, you can say on-click equal to let's say on-click, and the next will be modifier equal to modifier dot fill max width, and the button has enabled equal to is loading. If it is loading, it's disabled, and it's not is loading, and then it's enable. Okay. And then we are going to say code fold the button. So this is the button. First is the button. Next we say if there's error, error, it's nullable, right? If it's light, in this light black, the trailing lambda, then we can say x is 8, and that's it. So we got it trailing lambda, and 8 goes to text. If the error has value is not null, and the text will be the value of error. So in case this is not null, display the error message. And we say, oh yeah, the color will be color of zero x f c. Okay. And get the pose. Now we can say the pose if pose is not empty, right? It's list, right? If it is not empty, then we can say we put it into a lazy column. Lazy column, and we want to say the vertical lazy column, and this vertical arrangement equal to arrangement dot space by dot db. And so it goes from top to bottom. And then for this lazy column, we can just say items which items is post, and which goes to the trailing lambda. The post goes to text of post dot next items is and literally post dot title. Okay, now we can run our application. So generally, we just want to click on the button, and the button on click will be ViewModel.getPost, fetch post. Click on the button, and ViewModel has a regular function, fetch post, which has a coroutine launch, called the suspend function inside of API service, get posts, and this get post URL will call the API and get the text and decode it. So that's how this data flows from the repository to ViewModel. The ViewModel pass it to the view. Okay. So now now it's a fetch post. Click on fetch post. Okay, so click on the play button. Click on fetch post. And it's loading, and it return the posts. You can see the titles. So that's the example of real world using coroutine and suspend function, combining suspend function, and the make API calls in suspend function. And yeah. Okay.